speaker and share the screen. All right, let's see if it's working. Test, it's picking me up. Okay, looks pretty good. All right, so get rid of this. So I just wanted, here's the virtual machines. And one thing I wanted to mention is you get the 123 Windows machine here. Corley, this just takes you back to the Corley website where you can get it. This machine doesn't have a legitimate product key. Windows Server 2008 is one of the old versions where they don't really enforce the product key very much. So if you restart it, it will say you don't have a product key and make you wait like 20 seconds for a counter to count down before you can log in. So a lot of students freak out. Just wait about 20 extra seconds and you can get in. That's all the punishment is for not having a product key. But anyway, all right. What is this? More telling me something? Chat. Oh, there's something in chat. Please unmute yourself. That was from, I thought I did. I am unmuted. You can't hear me? According to this, you should be able, can you hear me now? Is anybody else able to tell if they can hear me? It appears to be unmuted.
We can hear you, Sam.
Okay. Yeah, but you can hear me now. Good, good. Okay, good. Fair enough. All right, that's good. Another thing I'll probably need help with in the future is having somebody watch for like tweets or something from students that are on the stream. I'm still new to this, and it's somewhat clumsy. Anyway, I just want to show you one more project because a lot of students are unfamiliar with command line usage and Linux. And I got a couple semesters ago, I decided, I looked online for tutorials and they were all pretty miserable, so I wrote my own. And so I put it here as an extra credit project. So I recommend, if you are not familiar with Linux or the command line, you do not need to be an expert in it. You could take a whole Linux course here, and that would be a very good thing to do, but you don't really need that much Linux. You need a little bit of Linux, and I put what you need here in this project X0. So let me just demonstrate this. This is a little bit of Linux, because as I mentioned, the project 2 is the only project where you're going to use the mouse here, really. Everything in Corley, you do it at the command line, and that's true of pretty much all Linux. So let's play with a few commands. The most important thing about the command line, which I learned from a long extinct game called Zork, is that you have to know where you are. See, when you have a graphical environment where you're clicking on things, you see folders and drives, and this doesn't come up. But here, you just see a command prompt and you don't know what's going on. Your first concern is, what directory am I in? And so you can do pwd to see what directory you're in, print working directory. I'm in something called /root. If I do cd, that will take me home. You have a home directory for your account, and in Corley Linux, you're always running as root, and the home directory is /root, which is, by the way, a poor security practice. And this is an important fact to understand. Attack boxes are usually terribly insecure. So you don't put secrets on Corley, and Corley is not something you want to do word processing on and shopping on. It's an attack box. It is designed to make it easy to launch attacks and not to protect you. If you want to use Linux for normal life, you use something like Ubuntu that is designed to be used in this fashion, and you're not running as root all the time, because running as root all the time is very insecure. But it's handier if you're an evil attacker and you don't care about protecting yourself. You're attacking other people, which is what we're doing. So ls shows you the contents of the current directory. And by default, it colors things. So there's something called desktop and documents and downloads and eternal and fun.exe. There's a few things in this directory. ls-l is usually much more valuable. This is the short thing that just gives you the names of objects. ls-l is the long form that gives you a lot of details about the objects. The D means directory. The minus sign means a file. So there's a directory called desktop, a directory called documents and downloads. Notice that they start with capital letters. One of the first really annoying things about Linux for Windows users is it's case sensitive. So if I want to look at my desktop and I try to change directory to desktop, there is nothing called desktop. It's capital D, desktop. And then I'm on my desktop. If I do ls, there's nothing on my desktop. Now I can go back to where I was. I can do cd ... takes you to the directory above where I am. Before I do that, let me show you something here. And let me move this, make it a little smaller, and zoom in a little bit. All right. If you do ls minus l, there's nothing here. But if I do ls minus al, then I see hidden files. And there are two hidden files in an empty directory. Two hidden directories. One is dot and one is dot. The same thing is true of Windows. Dot is the current directory. Dot is the directory above this. And it is the existence of this files that creates the tree structured directory. And let me talk a little bit about the Linux structure. The root of everything in Linux is slash. And by the way, it's forward slashes. In Windows, it's backward slashes. And in Windows, everything starts at something like C:, or D:, which is a drive letter, because Windows machines are typically laptops and you care what device it's on, your hard drive or a USB stick, or in the old days a floppy drive. Linux was intended for servers, and it dates from a time long before when you could afford your own computer. So you were using a server that was in the next building, and you had no idea how many drives there were, and it wasn't any of your business either. So there's no information in Linux about where your files are stored in a hardware, not obviously. The system just starts at a directory called slash. That's the root of the system. And if you do ls minus l here, you see standard Linux directories like dev for devices and boot for boot up information. And home is where normal users have their home accounts. But in Linux, we're running as root, and we're always starting /root, which is in Corley, which is not normal for other kinds of Linux. And these are standard places where things are stored. As in Windows, you have things like C Windows and C Windows System 32. These are the standard places where the pieces of Linux are stored. But normally, for what we're doing here, you don't wander around in the system folders. You stick to your home folder. So let me blow this up a little more. Just try to make it easy. Okay, ls minus l shows me what's in my home folder, desktop, and so on. Let me make a directory, mkdir, say 123 for this class. Now if I do an ls minus l, there is now a folder called 123. This is one thing worth knowing about Linux is the permissions. This rwx, r-x, r-x here, those are the permissions of this directory. The first three are read, write, and execute for the owner. And the owner is root. That's what's right here. I created it, I'm root, I own it. The next three are for people in my group. My group is also called root, and on Kali Linux, there's only one user, and it's root in the group root. So there really isn't much issue of which user owns things. Normally, there's only one user that ever uses the box, but in a more normal system like Ubuntu, there can be multiple users and your privacy and such. So this is what the owner can do. This is what other people in the group can do, and this is what everyone else can do. So the owner can read, write, and execute, and everybody else can read and execute, but not write. That's the default situation. So I can go into that folder with CD 123. Then my prompt changes. The tilde means I'm in my home folder. Tilde/123 means I'm in the 123 subfolder from my home folder. And usually, when you're going to do something, you make a new folder to keep it clean so you don't have a lot of junk in the way. There's nothing in this folder, or to be more correct, there's only the default hidden files in here, dot and dot, which are always there, and you don't want to remove them. So that's ls is how you see what you've got. You can do help. There's online help. The first thing, the most useful, is -- well, this is the second most useful. Okay, -- help gives you brief help, more or less brief, which is still scrolling off the screen, but here's a list of the arguments. A for all, do not ignore entries starting with dot, which is how they're hidden, and there's more and more options here. This is already probably more information than I want, and ls is actually one of the most complicated commands. There's another one, which I'll show you, called man for manual, ls, and this is page after page of every detail. This is far more information than you almost ever want. Both of these, in fact, are far more information than you almost ever want. So if you actually want to get something done, you don't use this help system at all. What's the best help system in the world? Google. Ignore your computer and use Google. Now you can get stuff like how to use LS, Linux, how to use LS. And you'll find a friendly tutorial written by somebody. This is much more helpful than the online tutorials. Those things date from a time before the internet, when you didn't have this option. Now that you have Google, this is real pen testers, just like real developers, steal stuff constantly from Google. Every time you get an error message, you Google it. Every time you forget how to do something, you Google it. That's how you get through the day. Anyway, so be aware of that. There is online help, but Google is your best friend. You will find a friendly tutorial written by somebody that pretty quickly that will tell you how to do whatever you need to do. So that's LS. Like I Googled Linux LS examples, and I found a lot of useful examples showing the common ones. This explains the columns, read, write, and execute, and so on. All right, so man LS, you saw that. All right, so now let's edit some files. All right, there are a couple of editors. How many people know VI? Okay, you guys have to leave. You're going to hate me. I'm too stupid for you. I can't use VI. You got it. VI is the most efficient editor if you have all the commands memorized. All I can remember is escape:WQ to get the hell out of VI. And then I use Nano. If you're a wimp, you use Nano. Nano is a very old, simple editor that you don't have to remember the commands. So I'm going to nano foo. This creates a file named foo up here. And right now there's nothing in it, and I can put stuff in that file. Okay, put in stuff. When I want to save it, the commands are right down here. The caret means control, and the letters appear in capital, but you don't have to press shift because this is so old. I don't know if, I think a couple people in this class might be old like me. Originally, there were no lowercase characters on the keyboard. There were only capitals, like in the 70s. And that's when this stuff was written. So Control X. And so Control X saves exits. It asks you whether you want to save the file. Yes is the answer. Your choices are yes and no and cancel. So I say yes, and then it lets me, I have a chance to change the name. If I press enter, it will take this name. So now I've created a file called foo. And if I do ls-l, there's my file. Here's the date it was modified. Here's how big it is, 16 bytes. That's how many characters I typed. Here's the owner and the permissions. And this is an awesome thing called the link number, which we don't usually care about. I'll just mention, if you are old enough to know about capital letters, you might also remember this ancient product called Windows 98 that was a thing to drive us all insane. And Windows 98 had a great feature. It would self-destruct. You'd be using it, you'd launch the program you like, and it would say, can't launch the program, missing dill, ms45734.dill. And so you'd have to go find that by opening this horrible thing called a cab file. And then next week, it would be gone again until you just want to cry. And Microsoft, in every later version, have more and more complicated things to try to put the dills back. And you still see missing dill errors on Windows 7, 8, and 10. They never really solved it. That's because, as in most other things, the Linux community solved this problem 35 years ago, and Microsoft did not yet get the memo. The link number tells you how many programs are using this file. So if I install a program that uses a library, the link number will go up. If I install another one, it will go up. If I try uninstalling the programs, the link number will go down. When the link number hits 0, it throws away the file. You may remember, if you're in Windows and you uninstall a program, it says, this program is using these 5 dills. Should I delete them? And I'm like, what do you mean? How do I know? Well, how do I know if MS14753 is still being used? I wish there was a computer to keep track of that. And that's what Linux does, and Windows does not. We will encounter a lot of these things where Microsoft just does things in a really boneheaded, backwards way. Now, Microsoft is much better about security than they used to be. But until the Trustworthy Computing Memo in 2002, Microsoft's official policy is that security is a waste of time, just ignore it. They said there aren't very many hackers, don't worry about malicious attackers, what's a waste of all our time and money, just put in more features so real legitimate users can get their job done, and make it so a normal user making an honest attempt to do their job won't crash it, and that's good enough. And then in 2002, Bill Gates finally said, you know, this is getting out of hand. Everybody has porn pop-ups and dancing alligators, and they can't get anything done. And we got to change our policy and start making our product secure. And they turned like the Queen Mary, you know, slowly, this gigantic enterprise, until they got pretty secure these days. But parts of their system are left over from the bad old days when they just didn't care and didn't even know anything about security. And this is one of the many ones. Anyway, so that's how you create a file, and you can modify a file by nanoing it again. You can change directories. You can make a directory like I've done. You can move files. So if I do ls-l, I have a file called foo, and I want it to be named bar. In Windows, there's a command called rename, but Linux was written by mathematicians. So they do not bother to have a command that you don't need. Rename is the same thing as move, logically. So it's MV. I move foo to bar. And now if I do ls-l, it's bar. That's you could call that rename, but they call it move. Anyway, I can make a copy of it. I could copy bar to bar 2. And now I have 2 of them. And I could edit one of them, nano bar 2. And I could put in more stuff. And save that with Control X, Y, enter. And now, by the way, you can repeat the previous command with up arrow, which is very handy, especially when you start getting long, complicated commands. So I can go to that ls-l again. And now you see I have bar and bar 2, and bar 2 is longer. And I can remove them with rm. So I can remove bar. Now you may remember, if you remove a file in Windows, it says, are you sure you want to delete it? Yes or no? And if you say yes, it puts it in the trash can. Linux typically does none of this for you. It assumes you're an expert. If you remove it, it's gone. Now there is something called a trash can on a desktop, which I don't think I've ever used. So maybe there's a trash can now. I'm kind of skeptical. But typically in Linux, once you do something, it's done. You're supposed to know what you're doing. And it just doesn't ask for confirmation. And when things work, you get no reply at all, because you're an expert. And also, you're typically writing scripts to do it automatically, so it doesn't bother to talk back to you unless there's a problem. So if I try to remove bar again, now it complains, there isn't any bar anymore, you already removed it. But as long as things are working, Linux says nothing. It's like an obedient servant. Yes, sir, I'm doing it. All right. So you can do output redirection. Here's a command with some output, date. This is probably the simplest Linux command. It prints the date and time on the screen. So you can print it on the screen, or you can put it in a file. If I do date greater than foo, then it doesn't print it on the screen anymore. The greater than sign is output redirection. That takes what was going to go to the screen and instead puts it in a file. So now if I do ls-l, there's a file called foo. And if I nano foo to see what's in there, it's got the date in there. Now, you can put other things in there. You can do echo hello to foo. If I do echo hello, it prints it on the screen. If I send it to foo, it puts it in the file foo. So if I want to see what's in foo, I can nano it. Now it has hello, but the date is gone. This is an important thing to know when you start doing this. The single greater than sign empties the file first and then puts in the stuff. Now you might want to add stuff. If you want to do that, I might want to put there in here. The way you add it is 2 greater than signs. That appends it to the existing contents. So if I do that and then nano it, now I got hello there. And this is important, and you use this trick a lot in your scripts to create something like a log file. Do something, put it in a log, do some more stuff, put it in a log, especially when you're making mistakes. This is a very common thing sloppy programmers do, and I'm totally in the category. When I get in trouble, I just put print statements everywhere. Echo A, B, C, D, and so how far did it get before it crashed? Made it down to C, well, that's where the problem is. And when I get really frustrated, which happens pretty often, I make a copy of the file and throw away half of it and see if I still have the problem. Then throw away the other half and stuff like that. Anyway, that's why if you take 124 where we're coding, you learn some basic rules of coding, but I'll just mention the most important rule of coding is to do a little bit at a time. A beginning programmer always makes the same mistake. They type 2 pages of code, they run it, it of course doesn't work, and they're hosed. They don't know where the mistake is. You put in 2 or 3 lines and test it. Then you put in a couple more lines and test it. Then you know where the mistake is. This is much more efficient. Anyway, but we're not going to be writing any code here except very simple stuff. So I'm going to do a little shell scripting now. We're going to write a program. This is the simplest kind of scripting. They call it batch files in Windows, and they call it bash shell scripting in Linux, where you take commands that you could have typed at the terminal and you automatically type them. So I'm going to make a script here. Let me make a simple one. I'm going to make a script 1, and I'm going to make it do date and ls and then echo all done. Okay, those are just commands to execute. Now, I can run it this way if I type bash first, and bash and then S1. Bash is the shell, born-again shell that I'm using here, the default shell for most Commandline Linux. And it will run those commands, print out the date, do an ls, and then print all done. If I want to make it so I can run it directly by just the name without bashing it, I have to add the shebang line. So I'm going to nano S1. The shebang line must be the very first line, and it looks like this, shebang, and then you put in the path to bash, which is bin bash. And that tells it, don't make the user type bash, execute the following commands using bash. You can also put Python here and then have Python code. So that means this program can run itself, so I can run it directly. I might try just typing the name of the program, S1, and then it can't even find it. This is one of the first baffling things about Linux. Your current working directory is not in the path. If you type the name of a program in Windows or Linux, it will now hunt for that program in a thing called the path, which is a series of directories, but my current working directory is not in the path. I have to specify it. Remember dot, I mentioned earlier, you have to put ./S1 so it can find it, because that tells it it's in the current directory, which is dot. Now, it found it, but it still won't run because there's a permission problem. Well, let's look at the permissions. Remember, that is ls minus l. Here's my script, S1, and the problem is I have read and write permission, but I don't have execute permission. And that's what I need. So I have to give it execute permission, and you do that with chmod, C-H-M-O-D, and you can just say add execute to that file. You can also use base 8 numbers if you're into that, but we don't really need that for simple stuff. Plus X will give it an execute. Now if I do ls minus l again, it's now got X everywhere. So now I can just run it with ./script, and there it runs. This is how you can make your own commands to do whatever you like. And there's a little bit more to it here. I put in a loop. Here's how you make a loop in bash. By the way, Kali Linux has VMware tools installed, so you can copy and paste, which will help you in the projects, especially when you have projects that have longer command lines. So I can nano, let's call this count. I can paste in that stuff. Unfortunately, it is not Control-V, it's Shift-Control-V. At the beginning, I would recommend using the mouse. Right-click copy and right-click paste until you get used to it. For some reason, nobody unifies this stuff, so the Linux commands to copy and paste are different than the Windows desktop commands, and the Windows desktop commands are different than the Windows command line commands, so it is pretty annoying. And for a beginner, it's a lot better to just always use the right-click, which works everywhere. But anyway, now I put in that stuff. I save it with Control-X, Y, Enter. I take a look at it. Now I have a file called count. So I try to run it. Okay, why didn't that work? It doesn't have the ./ I didn't tell it where it is, so it couldn't find it. It looked for it in various places like bin and sbin, and it wasn't there, and it gave up. So now I put in this. Okay, why won't it run? It's not executable. Okay, so I'll go back to my chmod plus X. And I'm a total slob. I'm just going to chmod plus X everything. Star is everything. This is the kind of stuff sleazy hackers do. Real people, real programmers are picky, but sleazy hackers are just about getting the job done. So that should have made it executable. And so it did. Now it prints out 1, 2, 3. Now if I do ls everything is green. Green means executable. And I've made some files executable that are not really scripts, so this is sort of sleazy and unprofessional, but I don't care. I'm just making a few files for me to use. I'm not planning to sell this to 1 million people and then have to have a help desk explain to them why these files have the wrong permission. I'm just going to break into a server, and then my job is done, and nobody's going to care how much of a mess I made of my Corley box. All right, so that's that stuff, read, write, and execute, and then a little bit of networking. ifconfig is your main tool you use here. ifconfig, in Windows, it's ipconfig, it's Linux, it's ifconfig, just to give us all a headache. They do the same thing. This tells you the status of your network interfaces. So you have an Ethernet interface, which is called ETH0. That is your real physical interface that goes to the network, although it's simulated. This is VMware. So it has an IP address, 192.168.1.188. This is the loopback address, which is always 127.0.0.1. So the loopback address refers back to the same machine. It may seem kind of nuts, but you can make a network connection back to your own machine. This is fairly commonly done, but it doesn't really make a lot of sense, but it is commonly done so one process can talk to another process. But the Ethernet is the one that really goes to the internet. So that's how you find your IP address with ifconfig. Now, you might change your network environment. Like here, for example, I could change from NAT to bridged. So instead of, now NAT means VMware simulates a router and it gives me a private address behind the router. But if I wanted to actually attack another machine in the room, like one of your desktops or something, then I would want to be bridged. So my virtual machine is connected directly to the City College wireless network. When I do that, Linux is going to ask me for a password, which doesn't always do, but sometimes. Now, there is a graphical connector sign up here. And when it works, this will gray out as the plug is disconnected and then light up again when the plug is connected and automatically get a new address. This fails a lot, like half the time in Linux. This is one of the many things about Linux that is just never bothered to fix it compared to Windows. You very often have to fix the network manually. And it looks like it failed here, which is handy for my demonstration. So if I do ifconfig now, I still have 172.16.1.188, which is not right because the network I'm on connected to, City College Wireless, uses 147.144. If I go to my Mac here, this is my host machine, and I do ifconfig, I have a lot of adapters, but the wireless adapter is this one, EN0. And as you see, the actual network we're using here starts 147.144. That's our network. So that's what I should have got here, and I didn't get it. So now if I try to ping Google, I don't get any replies because I'm not really networking because it did not renew the address. This is very, very common. Now, you may remember from Windows desktop support, when this happens, you can either restart the machine or you can do ipconfig/release, ipconfig/renew, or you can disable the network card and re-enable it to get an address. And you can do those things in Linux. You can just restart the machine. That would work. There's a restart button up here if you ever want to do it. That is, by the way, considered extremely unprofessional. This is one of the pride points of Linux people. Linux people have a real attitude about Windows people, but they are an inferior race and they don't even know what they're doing. By the way, Cisco administrators have that attitude towards everybody else too, because nobody else understands networking. You just think you do. Get a CCNA and you'll realize how much you didn't understand networking at all. And Linux has the same attitude. Most Windows users do not understand what the machine is doing very much compared to Linux users. Anyway, so it is considered unprofessional to restart the whole machine. You should know how to do things without restarting the whole machine. So the way to do what we want here is, there are two ways. Here's the sleazy way, ifconfig eth0 down. That disables the adapter. And if the GUI is working, which it only does half the time, that will vanish or turn gray. It actually worked. So now I have no networking. Now if I do ifconfig, I only have the loopback adapter. eth0 is gone. So I cannot talk to any other machine at all. Then you bring it back up with up. And now this little thing will come back, turn gray, and then turn white, and supposedly it got a good address now. Let's see. Now it did. It got a 147.144 address. So that did it. Now I'm going to go back to NAT. And again, what we ought to see here is this should turn gray and then white again. But once again, it's failing. So now I'm back on NAT networking, but I think I still have the wrong address. And I do. I have 147, 144. So now I'm off the internet again. So the other cure, then bouncing the interface, if you take it down and up, is to just get a new address. And the command for that is dh client. And I like to use -v so I can see what I'm doing. And for some reason, a couple of versions of Corley ago broke it, so you have to specify the interface or it won't work. You didn't used to have to. So this is the command to get a new IP address. So it now asks for an address. It gets an address, gives me some disturbing messages. This is probably why it didn't automatically do it. Some service has crashed, but it actually did get an address bound to something. So now if I do ifconfig, I should have a better address. One I don't though. Wow, this is really messed up. It still shows 147, even though that told me it got 172. Now that's really harsh. And I might have, yeah. But still, it said bound to this address, so that's what should appear here. I should mention another fact. This is a good point for it. Ubuntu is kind of for the birds. Ubuntu is your first Linux. It's the most like Windows. If you use Ubuntu for 3 or 4 years, you will begin to notice things like this that are disturbing. Ubuntu is based on Debian unstable. It is got the flashiest features, and it is the most buggy. When you begin to notice how much Ubuntu sucks, then you're ready to step up to a real main branch of Linux like Debian or Red Hat or Slackware, which are harder to use, but much more efficient and accurate. Ubuntu has a lot of bugs. Anyway, let's see if I can ping Google now. And I can, and I'm pinging from 172, but ifconfig is lying to me about my address, which is pretty darn harsh. That is really rude when the tool gives you the wrong answer. And I've never seen the command line tools, even in Ubuntu, give you the wrong answer, but there are bugs in it. There's plenty of bugs in Windows. Be aware, everything you use has bugs. That's pretty harsh. By the way, I'm supposed to be using this instead of ifconfig, and I wonder if this will give me the right answer, and it's still lying to me, giving me the wrong answer. Wait, oh, it has 2 addresses. Oh, okay. That's also kind of messed up, but it's not as messed up. I now have 2 addresses on the interface, one for this network and one for that. That's at least more likely to be true. But I don't believe ifconfig showed me both addresses. That is really messed up. But be aware of that. That's the nature of this, of hacking tools like Corley. They tend to be buggy because they don't go through the normal kind of quality control. They're used by experts that don't notice small problems or care. So you can do this part and just turn in an image. Oh, that's right. This is all just a lesson. To get your points, you have to make a script. Make a script that will print hello from your name, and then make a script that will print out other things, your name, a date, the directory it's in, and then do a ping. So, that's this project. And when you email that stuff in, you email screenshots. Wherever you see this hand, that's what you turn in to get points. Take a screenshot of your whole desktop with that on it, and then email it here, and my highly efficient grader will see it within a few days and reply, and you should get your score within a week. If you don't get a reply within a week, then let me know, then something has gone wrong. Sometimes the Google spam filter throws away the mail or something, and that's what you have to do for your projects, and you do have a couple of weeks to get started. So I think that's it. Any questions about anything? I'm going to go down to the lab now, Science 214. I'll help anybody that wants to work tonight. If you just want to go home and work from home, that's fine. Nothing is due until September 13th. Okay, I'll stop the live stream and clean up and go to the hacking lab. So, and we need